Okay. So, first problem is the antiderivative of, or 23. Somebody tell me what it is, because I can't pull it up right now. So the antiderivative, that's great. Antiderivative of what? X squared plus x dx, and from what values? -2 to 0. Okay? So you could break these up into, you could do this two different ways. You could go find the derivative of both and then do it, or you could separate it into two because of the positive, because of the product. You could do that. I don't care which one you do. This would be x to the third over what? Plus x squared over 2, or you could write it as 1/3 x cubed plus 1/2 x squared. Both evaluated at -2 and 0. Okay? And using the fundamental rule of calculus, just plug and chug. So that would be, now I'm going to erase this right here because you don't have to do it both ways. Now this is the way I show students to do it, so if you do it a different way, that's okay. This is pretty much the most basic way to do it. Parentheses cubed over 3 plus parentheses squared over 2 minus parentheses cubed over 3 plus parentheses squared over 2. And here I'm going to plug in what? And here I'm going to plug in -2. Now I'll do this one for you. What does that go to? 0. But be careful because of this guy right here. So right here we've got -8 what? -8/3. Right here you got a +4 what? Halves. Got to have a common denominator, which is 6. So let's see this. I knew it would do it. Fine. So that's going to be -6. 3 going 6. 2 times 8 is 16. 2, 3, 4 is 12. And -16 plus 12 is -4/6. That'd be 4/6, which is what? Should be +2/3. Say again?
Inside those brackets.
Yeah, I'm sorry. The negative times the negative is what? Yeah. Okay? That's pretty basic. Anybody got a question there? Let me ask you a question. Where do people have the biggest problems with these problems? The calculus or the math? The math. This is where students get it wrong. Right here. Now what causes a student to get it wrong? There's two things. Somebody tell me what they are. Huh? Yeah, but what are they? Give me the careless errors. The two biggest. No, not in this one. This one we're adding, and the other thing. I'm asking y'all to pick out the two most common things with this area right here. The negative sign out front, that's the first mistake. In other words, they forget that right there to distribute it at the end. And what's the other common thing that everybody has problems with? The denominators. common denominator. Okay? And that's the other thing people have problems with. Alright? So what's the next one? The antiderivative of what? Ugh. X cubed 3x squared dx, and from where to where? 0 to 1. Now, here's another way you could do this is you could break it up into 0 to 1 of x cubed minus 3, 0 to 1 of x squared. You could do it that way. That's just another way of doing it. I don't like doing it that way, so I'm going to erase that and do it another way. Do it my way that I usually do it. So, x cubed would be x to the what? 4th over 4 minus, be careful here, you have to do another step. 3x to the what? 3rd over 3, and the 3's cancel. So our final evaluation is x to the 4th over 4 minus x cubed evaluated at 0 and 1. Parentheses to the 4th over 4 minus parentheses cubed minus 0. And I'm not going to go through and do all that because I was only going to get 0. So plug in 1. And that's going to give us 1/4 minus 4/4, which is what? Negative 3/4. Okay? Say again. Everybody good? Now, basically, we've just done the fundamental rule of calculus. All right? I don't spend a lot of time going through the cracks and crevices. I just go ahead and there it is. Let's do some more. I think there's some more on 395, and then we'll look at a couple online. So, where's 395? Let me get my ebook back up. Where is it? There it is. I think it's 395. There's some. So let's work out some of these and then we'll move on. So go ahead and try 19, 21, 23, and then we'll move on. Let's do those three first, and then I'll let y'all pick out a couple. 21? Okay. Go ahead and do the first three, 19, 21, and 23. I'm trying, on what? Yeah, it's blurry, but it says, I think that's execute. Yes, page 395. Have they ever disqualified an NFL team before? I don't think they have, have they? If what they say is true, I think they should, but
It seems harsh, but Belichick,
it sets a precedent.
Belichick's been top before.
Huh?
Belichick's been top before. They coach, they playoff, they go twice to the playoff.
I'm sorry, what? It looks like it, but I'm gonna be honest with you. I think you'd be better off if you looked at the book, because I can't see on the monitor. Where? -1 and 4. Okay, that's the squiggle on the anti-derivatives. The more you blow it up, the more distorted it looks. One to 4, is that what y'all said? That's 5. 5 minus 2t plus 3t squared. Okay, 1 to 9. All right, I'm gonna pull this down now. And the first one, antiderivative of 1, from 1 to 2 of x cubed minus 2x dx, and that's going to give us x to the 4th minus 2x squared over 2, and that's going to give us x to the 4th minus x squared evaluated at 1 and 2. So that would be parentheses to the 4th minus parentheses squared, brackets, minus parentheses to the 4th minus parentheses squared, brackets. And 2's go here, and 1's go here. And 2 to the 4th is what, 16? Minus 4 is 12. Minus, what happens here? That's not rhetorical. Interaction needed. Thank you. And that's equal to 12. I had a student say, I thought 1 to the 4th was 4. Calculus. What's your question?
Is the x to the 4th, is it supposed to be divided by 4?
Yes, you're right. Thank you. I guess I just decided to leave off the 4 for some reason.
It's a negative 1. It's a negative 1.
Okay? I just changed the problem altogether. Y'all should have told me that at the beginning. It would have helped. Y'all all of them failed class now. I just did a different problem. Just decided to change the problem. How about that? All right. Sorry about that. -1. No, I don't need to take the other class. That'll be x to the 4th over 4 minus 2x squared over 2 evaluated at -1 and 2. And that's going to be x to the 4th over 4 minus x squared, evaluated at -1 and 2. And that's going to be parentheses to the 4th over 4 minus parentheses squared, brackets, minus, same thing, parentheses to the 4th over 4 minus parentheses squared. And here we're going to plug in 2. And here we're going to plug in -1. And we still get 4. Is this 4 right here? 4 minus 4 is what? I get 0. Is that what y'all got? Minus parentheses. And that's going to give us 1/4 plus what? 4/4, which is 5/4. And then the negative out front, I get what? -5/4. Okay, let's check it. This is 1/4. 1/4 plus, I'm sorry, minus, I was looking at the negative. And then, what, 3/4? 1 minus 4/4. Is that right? -3/4? And then negative is +3/4. Yeah. And you see that it can be very easily done to have a careless mistake. I actually changed the problem. Okay? All right? You know what's worse than a teacher making a mistake? No, teacher trying to persuade the class that he didn't make a mistake. Huh? Yeah, I've seen it. There's a couple that teach at Pendleton like that. They will go around the world to try to say that they didn't make a mistake. I just changed the problem. I made a mistake. No big deal. All right? Ready for another one? Let's do 1/4 3t squared minus 2t plus 5 dt. What did I do? I put it in descending order. For the last 12 years, if you've been taking math, what have you been told to do? Put it in descending order. And when you get to college, and you do that. I don't understand that thinking, but anyway, I don't understand what the purpose of writing it like that is. So unless they just want you to put it in descending order, so who knows? All right, so 3t to the 3rd over 3 minus 2t squared over 2 plus 5t. Evaluated at 1 and 4. Please make sure I didn't change the problem. Okay? Now the 3's go out, 2's go out, and that leaves you with t cubed minus t squared plus 5t evaluated at 1 and 4. Parenthesis cubed minus parenthesis squared plus 5 times parenthesis bracket minus parenthesis cubed minus parenthesis squared plus 5 times parenthesis bracket. And we put a 4 here. And we put a 1 here. Now, 4 to the 3rd power is going to give you what, 64? So I'm going to do another step here because I ain't Rain Man, okay? And some of y'all may be, but I'm not. So 64 minus 16 plus 20 brackets minus brackets 1 minus 1 plus 5. 5, right? 1 minus 1 is 0, 0 plus 5, make sure. I hate for you to miss it because of careless error. 64 minus 16 is what? 48 plus 20? 68 minus 5 is 63. And that should be what everybody got. And then the last one, first thing you do before you even start it is what? Rewrite it. 1 and 9, x to the 1/2 dx. It's going to be x to the 1/2 plus 2/2 over 1/2 plus 2/2. And that's going to give you x to the 3/2 over 3/2, which will give you 2/3 x to the 3/2, or 2x to the 3/2 over 3. So 2x to the 3/2 over 3 evaluated at 1 and 9. And that's going to give us 2 parentheses 2/3 over 3 minus 2 parentheses 2/3 over 3. And a 9 goes here, and a 1 goes there. Now, let's recall what a rational exponent is. What is a rational exponent? The square root of 1, or x to the first power, is equal to x to the 1/2. So you put the exponent over the what? Index, or the root, right? Exponent over index. So exponent, 9 to the 2nd power, cube root. So this is going to be 2 times the cube root of 9 to the 2nd power over 3.
I think you flipped let's see if we just rewriting that we have.
What?
You have 2x.
Got it.
You flipped the x.
I think I got to take a pill or something. I don't know what I'm doing. Why did I do that?
You didn't have to not do it.
Yeah. I just changed the problem again. Sorry.
Don't worry, it's Bush's bad.
It's called dyslexia, huh?
It's Bush's bad.
It's Bush's, it's all his fault. All right, so 2 parentheses. I know why I did it. I was looking at this 2 over 3, and evidently I just kept writing it. I don't know. Minus 2 times parentheses 3/2 over 3, and 9 and 1. So that's exponent over index, so that's the square root of 9 cubed. So 2 square root of 9 cubed over 3 minus 2 cube root, or exponent over index, is square root of 1 cubed over 3. Well, what's the square root of 9? 3 cubed is 27. That should be what you come up with there. Right? Y'all help me out. You can pull the 9 squared out.
Yeah.
You can do it that way. Okay, so you get 27, or whatever I said. I forgot what I said now. Okay. 2 times 27, 54 over 3. I have no idea, so we'll just write it 54 over 3, because I don't want to depend on the calculator. And I'll do this one for you. 1. I can't screw that up. 2 times 1 is 2. 2/3 minus 2/3. I get 52 over 3. And you can use your calculator, or you can leave it as a mixed number, whatever, it doesn't matter. Listen, if you do this and you get it down to this, I could care less whether you change it to a mixed number or whatever. Just make sure the directions specify That's where I can't give you partial credit. If the directions say write it as a decimal to the tenth, or to the hundredth, then you have to change it. I can't give you partial credit. Yeah. Okay? Y'all check that, make sure I didn't make another screw up. A dyslexia moment. All right, let's do a couple other ones that y'all were picking out. And I think y'all picked out the e to the x. And let's do a trigonometric. Okay, 26. Go ahead and write down 26. And 28. Huh? Well, I mean, we can do it. I mean, not that big a deal. And go ahead and do 25 while you're at it. 25, 26, and 28. What? 26 says, I can't even read, it looks like -2 or -3 to 5. That's a -5 to 5. Okay, -5 to 5 of e to the x. Is that a little bit clearer? I had to blow it up on the screen. How's that? I got to move it over a little bit. There. So, what is the antiderivative of the sine? It's the negative, what? Cosine, negative cosine. So, that's pretty self-explanatory. So, you're going to get negative cosine of pi minus what? Negative cosine of pi over 6. And crank it through your calculator. Now, antiderivative of e dx, that's real complicated. What's the antiderivative of e to the x, or e to the first power? E. And you'd evaluate that at 5 and what? -5. Or whatever, you know, you may have a e to the whatever power and you have to evaluate it. But what about 28? 28, why would 28 cause a problem? It's a conglomeration, isn't it? It looks like you. What's the first thing you think of when you see 28? Product rule, but there is no product rule. What do you mean there is no product rule? There is no product rule of what? Antiderivative or integration. So you quit, right? Throw your pencil down, quit. Make sure it makes that pop against the notebook paper, you know, pop! That means you thoroughly discussed it and you quit. Or you could rewrite it and distribute the t to the 1/2 power. All right, remember that. That's something very important. That's why I wanted to do this problem right here. Because this is one of those Patrick Star moments. Some people look at it on a test and they go, and they just sit there because they don't know what to do because it's a product. Just do it algebraically, and then you have the sum of two terms, and then you just break it up. So that one looks like it would be a pain, but it's not. Okay? So, somebody give me that one again right quick. The antiderivative from what to what? Yeah, 28. 0 to 4. 4 minus 2. T. 4 minus t. 4 minus t times square root of t dt. All right. First step: radicals in calculus. What? Don't miss. So what's the first step? Change the radical into what? T to the 1/2. So parentheses 0 to 4. And look what else I'm going to do. T to the 1/2 times negative t plus 4. And what did I do there? I put everything in the order that you were used to seeing. Now what am I going to do? Distribute antiderivative 0 to 4. Now be careful here. I'm going to write it out. T to the 1/2 times negative t to the 2/2 plus, and I'm just going to put that in front of it, so that'd be 4t to the 1/2 dt. Now, why am I writing this part out? Because this is where the screw up is going to happen, right here. What's 1/2? First of all, you got to, what's t times negative t? That's a negative t, right? But what happens to the exponent? What happens? You add them together, and what do you get? 3/2. So that would be negative t. I know y'all are impressed. All right, 0 to 4 of negative t to the 3/2 plus 4t to the 1/2 dt. And now you're ready to do the antiderivative. So that's going to be negative t to the 3/2 plus 2/2 over 3/2 plus 2/2 plus 4t to the 1/2 plus 2/2 over 1/2 plus 2/2. Evaluated at 0 and 4. And 3 plus 2 is 5, so that's negative t to the 5/2 over 5/2 plus 4t to the 3/2 over 3/2. And then that's going to be evaluated at 0 and 4. 2/5 t to the 5/2 plus 2/3 t to the 3/2. Say again?
Forty speed.
Did I mess up something?
It'll be.
Oh, yeah, I just ignored it. That's good. Good, Hubert. Plus 2/3 be 8/3. Thank you. All right, I'm gonna erase that side of the board and rewrite this over here. So make sure you got that down. Now, a lot of you may see already, how do I teach? I teach very methodical, and I teach very every what? Why? Because if you already knew the material, you wouldn't be in here, right? All right, now I'm not saying that as a review. I'm saying, that's the way I teach, because I'm going to get into the sections that you haven't been in, and that's the way I teach. Okay? So if you don't like it, I hate it. So, -2/5. And I'm going to go ahead and change this. Exponent over what? Index, so that's the square root of t to the 5th. Plus 8/3. And that is exponent over index of the square root of t cubed. Evaluated at 0 and 4. Now, what does the 0 do? Takes out the second term, right? So, we don't have to worry about the 0. So, all we got to worry about is the 4. -2 square root of 4 to the 5th plus 8/3 square root of 4 cubed. Now, what is the square root of 4? 2. So 2 to the 5th is 32, right? So -2, that'd be 32, plus, what's 2 to the 3rd? 8, Hubert. That's right. So check my math. Say again. Square root of 4 is what? 2 to the 3rd is 8. Square root of 4 is 2 to the 5th is 32, I think. Or 4 to the 3rd is what? 64. The square root of 64 is 8. 4 to the 5th, that's a BA number. I have no idea. So you can do it in your head if you don't think it, I can. So 32 times 2 is -64/5 plus 64/3. And you got to have a common denominator of 15, I guess. And that's negative and plus. And 3 times 64 is 196. Help me out. 192. Is that right? And 5 times 64 is 320. Is that right? -208. 128. I'm sorry. So that comes out to be 128 over 15. Thank you. So that problem may have looked like it was basic, but it had a little bit of algebra in it, didn't it? Because calculus, it wasn't very hard. Calculus was really easy. Question, right, complaint. What's the derivative of the sine? And what's the antiderivative of the sine? There you go. You got to remember those because those are a pain. You got to memorize them. Yeah, just memorize them.
Which is it where it's like one over the square root of?
Hold on, I'll show it to you. I got them already pulled up. There you go. Talking about the antiderivative right there.
Yeah, one over the square root.
And that's the arc sine and that's what we're going to get into in 5.6. That's what we start with the arc sines and the hyperbolic, but I don't spend a lot of time on the hyperbolic because you don't ever see it. You do see the arc sine in Calc 3 though. And I cover it more than I cover the hyperbolic. All right, let's see what else is in that chapter of review, because that's the second, that is the chapter review. The second part is chapter, whatever chapter this is, 5. I can't remember what we were in. Yeah, 5. And we just did around 5.3 where we are right now. Indefinite integrals, that's not a big deal. If you can do an antiderivative, you can do an infinite or a definite. I mean, it's not that difficult. They make it into something very complicated, but it's not. I mean, you could basically show all of what you need to know in one section, and they got it expanded out into 3 or 4 sections. So don't let it get you intimidated. But the only difference between a definite and an indefinite integral is what?
Or a definite one is,
It has parameters. It has A and B, and that's it. Question, right, complaint. And they show you how you can subtract rate of change. Not a big deal there. I was going to see, because I was going to look at a couple of examples here, but like I say, it's kind of redundant. Like this one right here. That one looks like it's complicated. Let me blow it up a little bit. I can't, I'm trying to look at both things at one time. See that problem right there? Just break it up into 4 little problems. The antiderivative of x to the 4th minus the antiderivative or 1/2 times the antiderivative of x cubed plus 1/4 times the antiderivative of x minus 2 antiderivative of dx. And the only difference is you don't have numbers here. But they did that back in 5.1 and 5.1 they showed you how to take the antiderivative, and now they're showing it to you again. So, I don't know. Maybe that's why I'm not writing books. I'll probably make too many mistakes. Alright. So, that one is pretty self-explanatory. What about this one? Exactly. That's another one. That number 2 is another one that people stare at. People don't stare at the first one because they know from Calculus 1 that if you have a product of terms, you just break it up. But the problem is when you have like number 9 or that problem we did a while ago where you had to distribute, that's where people have the Patrick Starfish moments and stare at it and go, I don't know what to do. Just rely on your algebra and get it into the one before it, number 7. Get it into that type form by using the FOIL method. Pronounce it however you like. 11. Again, it's a same thing, but what do you do with 11? What can you do with 11? 11 is a good test question also.
Break it up into 2 fractions.
You could do that. I'm asking y'all. That's not the easiest thing to do. That's okay. And breaking it up, huh? X to the what? Not the first power. When you bring it up, what happens? Negative. So you might want to do number 11. Let's do that one because that's a test question. I'll put up one like that on the test. And yes, We could break it up into x cubed over, but what are you going to end up doing with that? You're going to bring the x up anyway. So you can do it either way. See why people have a hard time with calculus? Because they always have to fall back on one. The algebra. You cannot have calculus without algebra. Ow! I shot myself. That hurt. Antiderivative of x cubed minus 2 square root of x over x dx. Yeah, that one is one that you stare at a little bit. And I'm going to rewrite it. X cubed minus what? To the 1/2 over x dx. Now, yes, you could do x cubed over x minus 2 antiderivative of x to the 1/2 over x dx. You could do that. And there's nothing wrong with that. But eventually you're going to do what with that x? You're going to bring it up, or you're going to use the quotient rule of algebra C1. So I'm not going to do it that way, but you can do it that way. I'm going to bring the x up. So antiderivative of x to the -1 times x to the third minus 2x to the 1/2 dx. So what is 3 plus a -1 or -1 plus 3? Thank you. Minus 2. And what's -1 or -2/2 plus 1/2? -1/2 either. Thank you for that. Huh?
Right up there, ball 5, till you get it.
All right. So now we're going to take the derivative, and then antiderivative, and that'll be x to the third over 3, no problem. Minus 2, and then let's take the antiderivative of x to the -1/2. So that's going to be x to the -1/2 plus 2/2 over -1/2 plus 2/2. And then that's going to give us x cubed over 3 minus 2. And then we're going to have -1/2 plus 2/2 is 1/2 over -1/2 plus 2/2 is 1/2. Dang old, multiply by the reciprocal, dang old 4. X to the third over 3 minus 4 x to the 1/2, dang old plus 2. And if you wanted to make it a little bit prettier, you do 1/3 x to the third minus 4 x to the 1/2 plus 2. Several different ways you could write it. It feel good? Everybody got the cobwebs knocked loose a little bit? That's the main thing we're doing right now this first week. Unless y'all wanna just jump on into it, I mean, we'd be glad to. That's a good test question. You're gonna get several of these and these. And that problem I showed you a while ago where we distributed the square root of x, that's another one. Indefinite. Where, somebody look at the syllabus. Where is the first two sections? I thought it was 5.6 and 5.7, but what is it? Somebody look in the syllabus right quick. Must be 6, chapter 6.6 and 6.7. It's the hyperbolic and the arc sine, or the arc trigonometric functions. I thought there was a 5.6 and a 5.7. That must be in the old book that we used to use. Okay, y'all find it in the next 15 minutes, you know. It's one of those difficult things that y'all have to find a handout. Right? Well, here's another one, 25. That's a good test question. Why is that one a good test question? Because we use the old dang old FOIL method. So try that one out. 25. It's a definite. So you might have to do a little bit of math. Darn, what happened to it? What number did I say? Thank you. There it is. And then we'll try to do 27. I was in the old, I was thinking the old syllabus. What is 6.1? I mean, what's the title of it? Oh, well, that's good. That's fun. Did y'all do any of that in Calc 1? Huh? Mm-hmm. And then that means you're going to fail. I'm sorry. There's always the ditch. Live in a ditch. $25.
When there is an infinite interval, you don't have a plus C. It's just
On a definite integral, no, because you're actually looking for the area. No, you don't put the C. The only time you put a C is when it's indefinite. All right, so we're going to use the FOIL method. Pronounce it however you'd like. And that's going to be 8x to the third plus 2x minus 12x squared minus 12x squared plus 2x minus what? 3 dx. Y'all check my algebra. And that's going to give us 8x to the fourth over 4 minus 12x cubed over 3 plus 2x squared over 2 minus 3x evaluated at 0 and 2. Now, do you also notice something else I don't do when I'm explaining something to y'all? I don't skip steps. Again, my job is to teach the material, not to assume you already know it. So that comes out to 2x to the fourth minus 4x cubed plus x squared minus 3x, and y'all check it against what y'all have, and that should be what you come out with. Now, luckily they give us a 0, so we don't have to do 0 because 0 takes out everything. So we just have to plug in 2. 2 to the fourth minus 4, 2 cubed plus 2 squared minus 3 times 2. And 2 to the fourth is 16, so that's 32. Minus 32. 8 times 4 is 32, right? Plus 4 minus 6. Dang old 32, 0. 4 minus 6 is negative 2. What'd y'all get? It's a miracle. We feel good about ourselves. Now again, how much of that problem is calculus? 10%? Maybe 15%? The rest of it's algebra and math. And once you break calculus down to its components, you start to see that it's not that what? It's not. I'm just setting y'all up for the slaughter is what I'm doing. Once you get your confidence built up, and then I just tear it out from under you. Say again? Huh? Yeah. And, you know, you lose your confidence, and then pretty much you drop, and then I don't have to teach no more.
Are you teaching the summer class?
No, they usually let Dr. Anzer teach the Calc 3 and the DPQ. I would love to. So, but let's do this one. 27. 27. So 0 to pi of 5e to the x plus 3 sine of x dx. Now, is this a problem that is easily, does it easily intimidate students? Yes. Why? Because it looks complicated. That's why. But is it complicated? No, because the antiderivative of e to the x is what? So that's not difficult. So if you ever get confused in calculus or any kind of math, if you go out to the real world, get confused, what do? You break the problem down to its what? Parts, to its base. So antiderivative, 5 out front, 0 pi of e to the x dx plus 3 antiderivative
of the sine of x dx. Well, we just said that the antiderivative of e to the x is what? So that's going to be 5 e to the x. And I'm going to put the pi and the 0 over yonder, so don't worry about it. Plus 3 times the what? The antiderivative of the sine is the negative cosine, evaluated at 0 and pi. So your final function, 5e to the x minus 3 cosine of x, evaluated at 0 and pi. And knock yourself out on a calculator. I'll do the 0 for you. No, 0 is not going to give you. Cosine of 0 is 1. So it's not going to give you 0. It's going to give you 3. So y'all crank that out. I'm not going to spend a lot of time on that. Okay? But the whole point of this problem, showing you this problem, is to show you that, just like in the real world, when you're given a problem, what do? Quit or break it down? You break it down. That's the whole purpose for 15 years of math if you're going to be an engineer. I don't want to cross a bridge with somebody that's had underwater firefighting math. Okay? Because they don't know how to solve problems. They don't know how to break a problem down to its parts. You're going to fall in the ocean and drown. Okay, what about 29? What's the first step? Change to what? I didn't hear you. All I heard was bring it up. Distribute. What about this one? What's the first step? Not the first step is to change what? Change the radicals. Then distribute. How about this one? Do we have to do anything? No, just break it up. You have to rewrite this. Try 32. We'll do 32. Make sure your calculator's in radians. Did y'all get something different or what? Well, that's interesting. I just lost my stylus. Okay, now we're in the hit pretty good. There. I don't have anything in there. Just pick up these things out there now. All right. I don't forgot which one we're doing, but 32. Says the antiderivative from 1 to 4 of square root of y minus y over y squared. Now the reason I like to do this problem, again, is this shows you how you can take a problem that looks like a cluster and do what? What can you do to it? break it down and simplify it into something that you understand. Or you could just what? Quit. Huh? Yeah, quit. Throw your pencil down. And just go, there you go. It's a little bit harder. Make that popping noise. There you go. And then turn the desk over and all that. Now, that's what I used to do. So, this is a cluster. Right here, this is a mess. So, first thing you want to do is rewrite everything and get it all on the same floor. So right now, you've got two different floors, and that's not going to help you. So, the antiderivative of 1 and 4, from 1 to 4 of y to the 1/2 minus y over y squared dy. Antiderivative of 1 to 4 of y to the negative 2 times y to the 1/2 minus y dy. And now you're going to distribute this, and that's going to give you 1 to 4 of negative 4/2 plus 1/2 is what? Negative 3/2 minus negative 2 plus 1 is what? Second? Negative y to the negative 1 dy. So now let's take this over here. And let's go ahead and take the derivative, antiderivative, y to the negative 3/2 plus 2/2 over negative 3/2 plus 2/2 minus y to the negative 1 plus 1 over negative 1 plus 1. Is that right? Okay. Evaluated at 4 and 1. So now we've got to simplify all that mess. What's negative 3/2 plus 2/2? Negative 1/2 over negative 1/2 minus y to the negative, y to the 0 is what? 1 over what? 0?
Ln of y.
Something's not. What?
No, like when you take antiderivative of y to the negative
1 over, yes, exactly. I was doing the power rule. I'm sorry. That would be the natural log of y, because du over u. So you're right. This is du over u. Rewrite this as 1 over y, and that's du over u. Thank you. And bring this 2/2, bring this 1/2 up. Let me erase this right quick because I don't want anybody to get confused. And that's 1 over y dy, which gives us that. And that would be negative 2. Actually, what would be best if you brought that downstairs, right? So that'd be negative 2 over y to the 1/2. Does that sound good? Or the square root of y minus the natural log of y evaluated at 1 and 4. And the square root of 4 is 2, so that'd be negative 1 and negative 2. So it's not, except for the natural log, this is pretty easy. Now, where is your algebra? Your calculus is right here. But the rest of it is all algebra. Okay, now, that pretty much takes us through whatever chapter this is. Section, I'm sorry, let me get to the top of the page.
The other page, let me bring this down. Well, they're supposed to put the daggum section somewhere on the page, but I guess they don't. Somebody tell me what page 404, what section that is. Let me get to the previous page, maybe I'll see it there. 5.4. So, right now, and I'll just put this on the board where everybody can see it on the video. Right now, we've covered review of derivatives, and that covers chapter 3. I want to say 3.8 through 4.5 or 4.6. Somebody tell me, is chapter 3, isn't it, limits? Okay, so I think it's like 3.9 or something, 8 or 9, up to, I think it's around 4.5. That's your derivatives. Now, what is the limit? That's the difference quotient, when you got to apply the limit as h approaches 0, and do the difference quotient. And I do put that on the test. I will put that on the test. And then antiderivative. The antiderivative is 5.1 so far through 5.4. So far. Okay, so that's where we're at right now. I will post homework on this, and that's what y'all need to work on. These two homeworks y'all need to work on over the weekend. Okay? Because hopefully we can get started on the new material next week. And that means I would like to give y'all a review test, and that'll give y'all another grade to help you out, you know, because it should be fairly simple, because it's a review over what you already know. Capiche? All right, let me pull the roll up, and then y'all can skedaddle. Looks like everybody's here except Mr. Fowler. How many people we got in? 3, 4, 5, 6, 7, 8, 9, 10. And how many people have I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Mr. Fowler's the only one not here. The rest of y'all are here. Y'all have a good day. Good weekend. I'll go ahead and post the